Hello, everyone, and welcome. It is Wednesday, the 23rd of March, 2022. It is time for the 97th in a row Knowledge Bolide Hangout, sponsored by Dhofar Spin Meteorites. I'm Dhofar, and the crew is behind me. Today, we have a topic that we've been looking forward to for a while, and a lot of our comments on YouTube have been, when are you going to do a show on Mars? So today is that day. We're going to have Mike Kelly give a little abbreviated 101. Meteorite 101 on Mars meteorites, the 4 to 5 different types that there are, and hopefully we'll be able to understand them a little bit more moving forward. I do want to show off some of my Mars samples. As you can probably guess, Mars and Martian meteorites are extremely rare. The entire group that they fall into of achondrites represents only like 6.3% of all meteorites. Then you keep dividing them out and dividing them out. You take out the Howardites, the eucrites, the diagonites, take out a bunch of other stuff, and there's a little sliver of Martian. So Martians are very rare, very special, and pretty dear to our hearts. So let me show you what I have. All right, I'm going to start with my smallest one. This one is important for one reason. Who can tell me, or why I like
the only observed Mars fall, I believe.
I don't know if it's the only one. It may be the only one. I know it's an observed fall. So
well, you got the type falls are all falls, but Zagami was kind of the first available Martian, I do believe, where they were doing like Bessie specs and everything else. I think that was kind of one of the first ones out there.
Yeah. So that is, I would love to get a bigger piece of that, but this is another one. This is Tindorf 002, and now we're getting up to almost 1/5 of a gram, and you can start seeing the texture. So we'll get a little bigger. If you guys stick around all the way to the end of the video, you'll see a 43-gram hunk of Mars.
Oh.
This one is from Oman, and we're getting up to almost 1/4 of a gram. This one only has a 1 kilogram of total known weight. And again, you can start, I have an external end, and you can start seeing the Martian texture. This one is super special.
Los Angeles.
Yep. We're going to look at the LA001 and LA002 later on and tell a little bit of the story about it.
That has a super fascinating find story. I love that find story.
Oh my God. Well, good. Hopefully you can fill us in on some details that we may be missing, because
yes.
Awesome. Okay. Well, this is my little piece of LA001. I'm super excited to have a piece of a American Martian. So that's cool. About 1/10 of a gram. Well, we can move up to a little bit bigger one now. Here's a 4-gram individual, but Mike will have to explain how this is different from other Shergottites. Excuse me. This is a Poikilitic Shergottite, sometimes called Laherzolitic, but this is 4 grams of the planet Mars. I love it. So that's the Laherzolitic Shergottite individual, and this is what it looks like sliced.
Cool.
Oh, that's awesome.
Wow.
This is a complete slice. It's 6.2 grams. And I noticed something when I was looking at it last night. Do any of you guys see the outline of the ridge around the top of this?
Mm. Mhm.
That's fascinating.
Kind
Mhm.
of weird, isn't it?
Mhm.
If we look on this side, it's even more pronounced
Yeah.
than what you're looking for.
Oh, yeah.
So I would imagine that that's a weathering feature, but I'm not 100% sure. I just saw it last night when I was prepping for the show, and I thought it was really interesting. Does anyone else have any opinions about what we're looking at?
Same opinion, weathering 4-5 millimeters deep.
Okay, awesome. Well, that is a Laherzolitic or Poikilitic Shergottite. I have a sample of Black Beauty.
Black Beauty, wow.
Mike later on during Meteorite 101 is going to tell us why the Black Beauty and all the pairings. This is not the original Black Beauty. I forget the number. It was in the 7,000s. But
7034 is the
thank
original.
you. That's good to have thesaurus on hand. Mike will tell us exactly why this was so interesting and important to science once we get to Meteorite 101. But I do have a small sample of that. And I want to show you the pride and joy, newest piece of my Martian collection, 100% complete slice of Black Beauty.
Ooh,
Yeah.
start drooling.
Dun, dun, dun.
Whoa.
Wow.
That works.
Wow.
Is that Black
Oh.
Beauty?
That polished?
Oh,
That
very,
is
very.
100% complete Black Beauty slice, and it's brecciated.
Wow.
Oh wow,
Wow.
that's nice.
What
Oh,
fraction of a gram is that one?
It is 0.071 grams.
Okay, well, if that ever de-ascensions from your personal collection, I call dibs.
Can you guys see the brecciation on this side of it?
Oh, yeah.
Yeah.
Okay.
Absolutely.
And then this white clast over here?
Yeah. Yep.
A lot going on for such a small piece.
Exactly. And let me put it away really quickly and carefully.
Don't let me anywhere near that, honey.
That's bucket list stuff right there.
Were you guys expecting a big baller slice? this is all. I was very fortunate and very happy to pick this one up. And this exact stone was assessed by Dr. Carla G. So we know
For
that.
Black Beauty, that is a big baller slice.
Yeah. I
Fun
was
slices.
I was super happy to get it, and then once before I bought it, I realized it was a full slice, and I was like, okay, that's mine, absolutely 100% mine.
Yeah, if that ever comes out of your personal collection, I call dibs.
Awesome. All right, yeah, I can't keep everything. I'm a dealer, not a hoarder. All right. Here, guys, is the much-awaited installment of Meteorite 101, the Mars edition. I'm going to kick it right over to Mike Kelly. If you would take us through, I'd sure appreciate it, man.
Certainly, yeah. So the question came up, well, how many types of Martians are there? And so there are 6 Dhofar. Back in the day, we had the original 3, which were the S, C, and N for Shergottites, Chassignite, and Nakhlites. But in more recent time, like you just showed, we have now polymic breccia, Augite basalt, and pretty old is orthoperoxenite. So there are 6 total, and they are all igneous types of rocks. The Shergottites are basalts, so those would be lava that actually made it to the surface of Mars or came within meters of it, so they're very shallow. And then you have the Nakhlites, which are cumulates. So again, they're basalts, cumulate basalts. So they settled out of like a magma chamber, so they were a little deeper than the Chassignite. They're igneous internals. And then you get down deeper and you get the Chassignite, which would be the equivalent of a dunitic material. So they are basically the equivalent of like a diagonite from Vesta. They would be the same composition basically from Mars. So
I have a question, Mike. Sorry to interrupt, but I'm going to. You said the original three classes were S and C: Shergottite, Nakhlite, and Chassignite. And I think, if I heard you correctly, that also represents the depth they're found in the planet.
Certainly. So yeah, it represents the composition and what type of mineral grains form out. So yeah, they relate to basically depth. So Shergottite should be shallowest, then Nakhlite should be a little deeper in a magma chamber, and then Chassignite would be the base of the magma chamber, almost like a mantle material, unaltered.
Thank you.
Yeah, no problem. So yeah, the SCNNs are all actually named after the first type fall of their kind, and Shergottite fell in India in 1865. It was a 5 kilogram fall, so it's a decent sized fall. And that's the most common type of Martian meteorite we have listed in the MetBull, with 276 total as of Monday. The Chassigneites are rare. They were named after Chassigny in France, which fell in 1815, which was the oldest of the type falls for the SCNs and Martians. That was a 4 kilogram mass. And what's interesting is, out of that 4 kilograms, as rare as it is, we only have 1 kilogram preserved.
Wow.
So a lot of lost material, which is kind of sad. And it's an interesting group because it's based on only 3 members, and nowadays typically MetBull and the Messauoud approve based on 5 members. But it's got its own grouping, and it is a very rare form of Mars. Besides Chassigny, you have NWA 2737 and NWA 8694, and both of those are not huge masses.
Wow, no wonder why Chassignites are so hard to get. There's only 3 of them.
Yep. And then you got the Nakhlites, which was named after Nakhla, which fell in Egypt in 1911. And the kind of cool thing about that is it's never been 100% confirmed, but the allegations are that it hit a dog. So,
Well, it depends on the breed as to whether or not it was significant.
beyond my realm of comprehension to say whether it happened or didn't happen, and whether it's relevant or irrelevant. But that's how the story goes. And there are 27 of those. So there's not a terribly large amount of Nakhlites either, which you would expect, because you figure you got to hit Mars with an asteroid or a large meteorite in order to get meteorites off of Mars and into an Earth-crossing orbit. And so the surface material is going to be most represented, and the deeper you go, the bigger of an impact you would need to eject that material. So it would be more rare. Looking down, then you have the polymorphic breccias. That's what Dhofar had showed the full slice of. Ben was right. 1734 NWA is the original one. It was found in 2011. It is nicknamed Black Beauty because of its physical characteristics. And what's really interesting about that, which Dhofar mentioned, is it really tells us a lot about the moisture content on Mars. Based on the age of Black Beauty, it gives us an idea of the fact that water was on Mars much longer than we originally thought it was on Mars. And also it gives you an idea of when and how much water was there, because that's one of the most moisture-rich meteorites that we have. Mm-hmm. So it's a pretty interesting meteorite.
Another thing that was interesting about it from a scientific viewpoint, we always talk about saving money on science, is this is a breccia. It's a compilation of many Martian rocks all melded into one and sent to Earth for us to digest and to research. So it does what Almahata Siddha did, delivering multiple lithographies, multiple types of meteorites in one fall.
Yeah, it's a very good point. Moving on down, there is a one and only Augite basalt, and that's NWA 8159. So it's got a separate basaltic composition that doesn't tie into the traditional SC or N as far as the compositions for its chemical melt makeup. So it would have come from a separate magmatic source than what we were seeing for the SC and Ns. And then finally, you have the single and only orthoperoxenite, maybe one of the most controversial meteorites ever, Allen Hills 84001.
That's the one that, had like life forms in it.
Tubules, yeah. it's got microtubules in there, and back in the day, NASA looked at those microtubules and also some carbonate deposits in there that kind of looked oddly bacterial as far as their shape. And that was brought up the questions of, hey, do we have proof that there is life on Mars? Which ultimately was later discredited. But it is still a 1 of 1 orthoperoxenite.
Yeah. And you ain't getting any of it either.
No, yeah. So 84 would be pre-ban Antarctic or post-ban Antarctic. I'm sorry. So yeah, it's not out there. It's one of those unobtainable types. So yeah. So what do we know about Mars? So what's really interesting is we have 0 sample returns, unlike the lunars. So besides the science done remote on Mars, these are the only in-hand samples that you can do advanced science on Earth that you can't do on Mars, like throwing things under a scope or making a thin section or running a SEM on them. You know, all that has to be done in a really controlled lab environment, which would be on Earth. So this is where we get all of our information from. And we figured out that these rocks were tied into Mars. The kind of the nail in the coffin was to look at little microscopic bubbles of trapped atmospheric gas from Mars that got stuck inside the melt parts of the rocks when they were ejected. So large asteroid or meteorite impacts, you end up getting shock melt going on. Some of the atmosphere gets trapped in that shock melt, and under controlled environments, they broke into those micro bubbles in the lab and looked at the noble gases and figured out that based on Viking data, where we sent a probe in and pulled noble gas composition from the atmosphere, it matches like dead on for what we're finding in those meteorites. So that was our final proof. But they do also share bulk iron compositions, right? So you see a lot of Earth basalts, and someone says, well, how do you know basalt is from Earth or from somewhere else? So Mars, right? We got a lot of oxides on the surface that give it that nice red color. But that also translates into a higher iron content in the rocks themselves that aren't necessarily on the surface. So the bulk iron composition for Mars is like 17%, where on Earth and basalts, it's like 10 max. So that's a way to tell them apart. And then you also got things like the isotopic, which we've talked about in separate terms. You know, all these things plot together, and they plot in that range where you would find Mars fractioning going on. And the other thing is the majority of the meteorites we have, you know, are some of the earliest material of the solar system. Most of them are in the billions of years old range. Mars was volcanically active in the millions of years old, which is very young, right? And the majority of the Mars meteorites we have all have a very young age for solidification. So that basically eliminates almost everything else besides Mars as being a volcanically active recent parent body. A bunch of proof that what we have is from Mars.
Mike, I have a question for you regarding the bulk iron content. You say it's much higher on Mars than it is on Earth. That confuses me a little bit because I know Mars is not attracted to a magnet. So can you help me understand and wrap my head around that a little bit?
Right. So yeah, so it's not free iron. It's iron incorporated into things like olivine, right? So olivine in itself is non-magnetic because the iron molecules are bonded into the mineral structure. So yeah, so when we talk high iron content, we're not talking free iron, which would relate to magnetism, you know, attraction to a magnet. We're talking mineralogically bound iron.
Awesome. Thank you for clarifying that for me.
Yeah, and it's also a bulk thing too. There's not massive amounts of iron on Mars. There's a very thin layer of red oxides on the surface, and that's why Mars looks red to us. But when we look at a Mars meteorite, they're not red. They're usually green or black.
I touched on this a little bit. You know, this is all the Mars we have that we can get samples of until we get around 2030 something, and we get sample return attempts from NASA from what they're doing right now with the rover. So again, it gives us access to samples, like Dhofar said, at a cheap, affordable rate compared to something like a sample return. You know, we do have 330 total Martian meteorites. So we do have a diverse sampling of Mars, even though the theory is we probably only have maybe like 10 or 11 sites covered on Mars. So there's probably a lot that's out there. That's a composition that we don't recognize, that we just don't have samples of yet. I already covered the water part in Black Beauty, since I know you found that interesting, Dhofar.
Yeah, really.
Yeah, and the other cool thing is this tells us, this is a case of meteorites going beyond meteoritic science and being very helpful for things like planetary science. So understanding the composition of the Mars meteorites and understanding their formation processes helps us to understand something like, whereas we have plate tectonics on Earth, no plate tectonics on Mars. So none of these materials are being reworked and subducted again, pushed back down and remelted. So they tell us that the mantle of Mars is not really homogeneous, kind of like the mantle of Earth, where it's being remixed. Since we have different compositions from different areas, we know that it's kind of different melts all together that make up the mantle, and they're all separate little compartmentalized areas. So yeah, that was pretty much everything I had for the 101. If anyone has any questions, let me know.
I thought it was a cool point that even though we have 300 plus Martian meteorites officially classified, we have a sampling of only a dozen sites thereabouts. Like when we get into the lunar and moon show, we're going to be able to talk about where those samples came from. How do we know where these Martian samples came from within or within the planet of Mars itself? Does anyone have any answers about that?
I got some stuff on that, Dhofar. So
Yeah.
while I was researching to do this, so they use a couple things, right? So obviously you need to be of an impact of a certain size in order to hit certain depths and actually get material to leave the planet of Mars. So they look at the size of the craters, right? And then they start doing a process of elimination, saying, not enough energy input to make a crater of that size to go ahead and throw material out of orbit so that we can get it as meteorite. The second thing they do is they do from orbit spectral scans. So they're looking at the spectra of the material, and they're looking at the spectra of the samples we have, and they're trying to make a corollary match, which would further down select which craters these might have come from based on visual spectra.
Yeah, there's this source that I have says that in a 2014 paper, they claimed that all Shergottites come from the Mojave crater on Mars, which is something like 58 kilometers in diameter.
That's awesome. Wow. And we have close to 300 samples of Shergottites here on the planet. It's mind-numbing at times when you sit back and realize what it takes to have that Martian sample delivered to our collections. I mean, the impact event, escaping velocity, traveling around in its space life until it finally gets pushed in the right direction to come to planet Earth, not shoot past us, not come at the wrong angle. 80% of the time it's going to land somewhere where it's not going to be recoverable. Then to actually have it recovered, identified, given to science, classified, then find its way to collectors. It's a very, very rare thing when it happens.
Oh, there's Bob.
Bob Varnish. Is that how you say his name? Varnish. He is the proud owner of the main mass of LA1 and LA2. These are the only American Martians.
I actually think one of them got sold a year or two ago.
Oh, he's the main mass holder on record as far as the finder and realizing that he had something special. The sample I showed you earlier is right here. Shows a little better. But Allison, you had some information about the find of LA001 and 002?
Yeah, can you guys hear me okay?
Yeah.
Okay.
Yes.
Yeah, so he was a rock hound for a lot of years, and he had went rock hounding in California in the Mojave Desert, and he'd picked up LA1 and LA2, both of them. And they just caught his eye, so he put them in his rock collection, and they sat there for like 20 years. And he had many crates of rocks that were up against the edge of the garage, and his wife kind of nagged on him a little bit one day to go through that and clean it up. And he had about 5 years prior started collecting meteorites. So this time when he went through his rock collection, he recognized the fusion crust on those 2 meteorites, and he took them. Where did he take them? To Arizona State University? Is that where he took UCLA?
Probably
Probably
UCLA.
UCLA.
Dr. Ellen Rubin. Maybe?
Yep.
Yeah.
Yep. Where they were confirmed to be meteorites. But yeah, they'd sat in his collection for approximately 20 years.
Oh.
And to the best of his recollection, LA would have been approximately where they were collected.
But the sad thing is, because they were not documented when they were found, he has no idea where to go back and look for more.
Yeah.
So you're looking at a lot of money
And
per
Dhofar,
gram. Go ahead.
That's a one of 2 American Martians. There is another.
Mm.
I'll show you the other one
Right.
later.
Or New Orleans or Lafayette or something.
Lafayette.
Lafayette. That may make an appearance later on, I think. If you guys want to take a look at what Mars looks like up close with magnification, this is what it is. This is a 14, almost 15 gram slice of Mars under medium magnification.
Wow.
Hey, Topher, that's a good segue because you asked the question on what Poikilitic is.
Yeah, thank you.
So you look at this and you can see those long crystal laths in there, right?
Yeah.
Mhm.
Yeah.
And they're needles of one mineral type, right? So when we talk poikilitic, what that means is it's one mineral grain that formed early on in the magma, and then it got moved kind of up, and another mineral formed around it, right? So you have this encasement in the poikilitic shergottites, where you have one mineral type encased in another mineral type throughout the entire specimen.
Interesting.
So that's what poikilite means.
Wow.
That means it took a long time to cool.
Well, it formed crystals at a deeper portion in the magma chamber, and then as it pushed up and the pressure and temperature changed, the moisture content changed, and as you know, more stuff solidified out of the magma, the actual composition of the chemicals available to make minerals changes. So yeah, it could technically be a slightly quicker cooling process, but it's usually like thought to be bimodal. So deep formation of one crystal, move it up in the magma, form a second crystal around it.
What I heard is it's pointy, so it's poikilitic.
That how
That's
you
one way
remember
to
it?
remember it, I guess.
If that lets you sleep at night.
Microscope work.
Jeff, are you going to show this later on?
You betcha.
Okay, skipping right over to this. You do not look behind the window. Okay, this is not this piece, but there's 2 pieces here that represent over 50 grams of Mars. But if you notice, these are paired to the Nakhlite or the Nakhla fall. So these are Nakhlites. This unfortunately is not mine.
Nice crust.
Yes. I
That's
filmed this-
I'm not used to seeing nice crust on a Martian.
Yeah, it's very rare to find Martians with really nice crust, besides falls. That's beautiful crust. Yeah, these all belong to Mark Lyon, and I filmed them down in Tucson, I think 2 years ago. But just a really unique looking interior. Let me see if I can get a little pause. Okay.
Topher, and since you mentioned fall, just another fun fact, there's only 5 total. Besides the SCN type falls, there's only Tissot and Zagami.
Wow.
That's
Yeah.
it.
Jeez. If you look at this texture here, you'll notice that it's not elongated, excuse me, crystals like we saw on the last slice. So yeah, so that was That was the Nakhlite that I really wish I owned. I can show you now this 4.4 gram piece of Nakhlite that will show the texture really well.
So that was a basaltic magma at the bottom of the magma chamber, the Nakhlite?
Yeah, Nakhlites are cumulates, so they're at the deeper portion of the magma chamber where things kind of settle out.
So that is what a Nakhlite looks like. And this one actually has fusion crust.
Wow.
That is.
Oh my.
That's cool.
That's a meteorite to me. That is-
Anyone want some Mars micros?
Beautiful. Yeah, you just made more micros there.
Yeah,
4 or
anytime you touch it, you make micros pretty much.
Wow.
But this is the largest piece of Nakhlite that I have. But it's
I
not.
hope that's not disintegrating in your fingers.
Well, I don't touch it very often.
That's really distinct.
Yeah.
It looks totally unique and totally different. Here is my largest one. This is the 43.5 gram Martian with fusion crust.
Oh,
Cool.
If you look
you
at
can
it,
throw that at me any day you want.
it looks like a Nakhlite. It looks similar to a Nakhlite. Do you see it? I wonder if it's just a super fresh Shergottite. I would love to have your guys' opinion. This is an unclassified Martian.
It is unclassified. Okay. Wow.
Yeah, the colors are much brighter, like it is fresher.
I'll have to send you guys pictures of this because the camera is really pixelating it right now, but it is absolutely beautiful. Green, orange, it's got voids in there, and it's super dense.
Veinlets in there?
Are you going to classify that?
No.
Is it for sale?
No.
Which armor leg are you giving up?
I have to know what it is before I make any decisions, but the more I look at it, the more I wonder if it's really a Shergottite. I don't know. But I'll tell you what, it could be the purchase of the year if I bought it as a Shergottite and it turns out to be a Nakhlite.
Oh.
So that's maybe I'll get some people with experience with Martian to contact me and help me out with this one. But that's 43 grams of Mars with a side of fusion crust. Yeah. Boom.
Don't get much better than that.
No, there are some things that are better because that's not classified. I would love to have it classified. That way I can say with authority, here's what this is. There are a few things that Mike Kelly has that are classified and they are significant. And the good thing about Mike is his show and tell. He tells a lot when he shows stuff. So let's see if Mike is ready for show and tell. And I've already seen the selection that he has picked out for us.
Turn my camera around. Sticking with Nakhlites, let me get this to focus. This is a very tiny one. Let me know if it does focus. There we go, I think. So this is rare in the fact that this was one of the first 3 Nakhlites recognized, Governador Valadares from Brazil.
Wow.
And this got even more rare because unfortunately in 2018, the Brazil National Museum basically in totality burnt to the ground.
Yeah.
Yeah.
And the main mass of Governor Valadares was in Dr. Zuccolato's office. And it was one of the meteorites that was not recovered after the fire.
Wow.
They got lucky that they found a lot of the pieces, but some of the small pieces, and I think the original find mass was only like 190 something grams, I think, on this one, was not found. So that, unfortunately, the majority of that is lost. And that's kind of why it's important to not have all your eggs in one basket with meteorites.
Yeah.
So it is good that pieces of these things go out to other institutions and even in private collections to spread the material around and make sure you'll be able to have some left should accident occur.
Mhm.
I talked about Chassignite.
Ooh.
So that is 2737. Stabilize my phone so I'm not driving you guys nuts. Sorry about that. So yeah, that is a 1 of 3 Chassignite, and that's my biggest piece. So I'm happy to have that much. It's super thin cut, and even that is still only 0.054 grams.
Damn.
But at how much that goes for, that's one of my happiest Martian pieces.
Yes.
Oh, boy.
I'm super jealous because I have none.
That's very cool, Mike.
We mentioned that there were 2 American Martians, one being Los Angeles and the second being Lafayette. This is about all you will ever find on the market for Lafayette, because
where's it from?
I'll have to go look at who I grabbed it from. It was one of the IMCA folks that had it for sale.
Well, I mean, what part of the U.S. was it found?
Oh, sure, certainly. So Lafayette was an interesting story in the fact that it was found in the biology draw of Purdue University. Yes, nobody knows how long it has been sitting there, but someone recognized that it was a strange rock, and so it was sent to the Field Museum of Chicago to be analyzed, where with its beautiful flowing fusion crust, they realized that it was a meteorite. It's a highly oriented meteorite. And it's a Nakhlite.
Wow.
So it's 1 of 27, and it's what I consider one of the crown jewels of the meteorite section of the Smithsonian Museum. They have the oriented face sitting there. Field Museum of Chicago, I think, has like 2 grams. And basically everything on the market was crumbs sitting in the box.
Oh my God.
So that really is all you get to see of it.
Oh man.
Yeah, there are really important meteorites like that are all tied up in museum and research collections that we'll probably never get our hands on.
Yep. I thought this was a cool one. When we sent the latest paper to Mars, they put a piece of SAO 008 on it. SAO 008 actually shares a classification with SAO 005, which is what this is. And it's now one of 2 meteorites that's been returned to Mars.
That is so cool.
And the science behind it is really cool too. These are targets for the ChemCam. They're calibration targets. And so we decided to use a real Martian meteorite as a calibration target. That's awesome.
Yep, it's that piece right in the dead center of the top 5 targets up top.
And that really speaks to the confidence that science has in the meteorites work that we are collecting with them. That they're going to send this mission to Mars and use a Martian meteorite to calibrate their tools.
Wow.
And last one I have is just a little spec, and this is the 8159. So this is that Augite basalt that that is a 101.
And that is a super rare, super expensive Martian meteorite.
Oh yeah.
I'm happy to have that tiny little piece.
Wow. Yeah, the list price on that stuff. I mean, you can get it cheaper, but the list price is basically $10,000 a gram.
Yep.
It's insane, but it's 1 of 1. And if you're a type collector like Mike, you got to have it.
Yeah,
exactly.
Yeah, talking
Not the
about
only one.
Mike, I wanted to show my appreciation for Mike week in and week out doing the Meteorite 101. And you know, you're dropping a lot of knowledge, little mini bolides on us week after week, and we here at the crew really appreciate it. But you're also creating a fan base of your own on YouTube. You are the hidden hunk of the Hangouts. There are females who comment about how cute Mike Kelly is and how we should have him on camera more.
You should make sure that his wife's not in the room with the
So
I'm in a hotel on travel, so I'm actually okay and safe.
So I thought that would make your day to know that not only does your big brain make you sexy, but you are a good-looking man.
You made my day. That is hilarious. I did not see that.
Yeah, I had no idea that it was that that's what they were watching you for. But there you have it, man. It's the brain and the looks. Continuing on good-looking, beautiful people. My wife Sue has a little announcement regarding a little mini announcement. Go for it, Bibs.
Hi guys, how you doing?
Hello.
Well, I'm not going to go into a full-blown MetBull update, obviously, since we haven't reached the end of the month yet, but I did want to do a mini update, especially since at Dhofar Spin Meteorites, we get a lot of requests from our customers who have purchased from us already asking, hey, did that NWA XXX get classified yet? And so we actually had 2 different meteorites classified in the last maybe a week or 2. So I started actually, after I had written out all the tiglets as a pending classification, Dhofar told me, guess what? It just got classified. So I'm like, okay, I got to start over on those. So tiglet did get classified. We sold some of that at our live sales. So it is an Augite. It's a witness fall, and it's listed as falling in southern Morocco. And we also had NWA 14686 get classified. And that one we expected to be classified back in, I think, January, but it took a little bit longer. I don't know why, but it might be because everyone assumed it was a feldspathic breccia, and it turned out to be a fragmented breccia, which I think might be more rare because it's only 1 of 17. So I know there are people actually like on the call with us. Greg and Jeff who bought some of that from us. So you'll get new COAs next time you guys order. So that is all. I just wanted to let you guys know 2 new meteorites.
Awesome.
Thank you.
So much. Yeah. I was pretty pumped that the Lunar came back. When I double checked, I'm like, wow, it's not just a feldspathic breccia, it's actually a fragmental breccia. So pretty interesting. If
What was it again? NWA.
NWA 14686.
14686.
Yeah.
Thank you.
And it is really a beautiful looking lunar. So
Yeah, it is.
I have a few pieces left if you're so inclined to get
We
one.
only have 2 left.
Oh wow, yeah, it's beautiful, beautiful lunar. And I was really happy that the class. It's not my submission, so I'm not trying to portray that it's my classification. But I was happy to see that they came back with a fragmental breccia rather than feldspathic breccia. Just a little bit.
Yeah.
A little bit more rare, a little more special, and ticks another box. Besides being a beautiful lunar, it's actually a rarer one. We had a little bit of a update to offer on the origin of Martian meteorites with a new crew member, Getty. Getty, how are you, bud?
Doing great. How are y'all doing?
Wonderful.
All right. So yeah, a comment earlier was stated that according to a 2014 paper, all the Shergottites came from a single impact event from a single crater on Mars. But I have a piece in my collection, NWA 12241, and there was, I guess, a presentation at the Lunar Planetary Society conference back in 2020, where they had a publication. They were looking at this 12241, originally classified as an olivine gabbro in the meteoritic bulletin, but they did some additional analyses on that, and the conclusions that they came to, according to its bulk and mineral composition, as well as its texture, it's similar actually to the Poikilitic Shergottites. And however, due to the presence of birefringent plagioclasts, the meteorite possibly originated from a different ejection event and thus a different location on Mars from the other known Shergottites. So it seems that we do have potentially another sample site from these Shergottites, not just the one, which was originally believed.
That's super awesome. I really appreciate you jumping in with that information.
Yeah.
And doing it twice now that we're recording. Thank you.
That's an eye-opener.
Yeah.
I have to say, I'm very impressed with all of his pronunciations.
Yes. Yeah. And he's giving Mike a run in 2 categories now. Hey, let's check in with our friend up north. Oh, it's on screen, guys. This is Jeff.
How's it going?
Oh, do you miss her? Do you miss her, Topher?
Yes.
Precious. Yeah, no, so this is NWA 12594. It's 16.712 grams. So not as big as the other chunk there that Topher showed, but that being said, this is definitely what I would consider Mars' third moon. It's definitely the prize in my collection, that's for sure, as far as that nice, beautiful fusion crust.
And rollover lipping.
You betcha.
Yeah.
Oh, yes, absolutely.
Yeah, the bottom side shows a near complete rollover lip, and the top side actually has radiating fusion crust that is super thin in the very center and gets thicker as it is blown towards the edges.
Yeah, this thing is amazing.
Oh, that's beautiful.
Yeah. There's the top of it. Jeff, do you mind if I throw some video on real quick?
You betcha. Go for it.
Okay. This will help everyone appreciate the gorgeousness of this piece. Look at that radiating flow on top.
Mm-hmm.
I love this piece, Jeff.
Like I say, I sleep with it under my pillow.
There's some sales that there's some sales that haunt my dreams, and this is one of them. It's just a beautiful, beautiful Martian meteorite. You're really not going to find something with this fresh of fusion crust unless it's a witness fall. It's shiny, it's beautiful, and it's almost 17 grams. Yeah. Thank you so much, man. That's freaking awesome.
You betcha. No, thank you.
It's the rarest, most beautiful Martian I've ever had the honor to own temporarily or curate temporarily. Our last and final show and tell member for the night, Mr. Chris Monk, everyone.
Monkman.
I feel a little intimidated after watching that.
No, man.
So when I was putting together my Martians, which I only have 2 of, I actually found a mistake in my collection because I had this labeled as a lunar, it was labeled as NWA like 12974, which I also own, but that's a lunar. So I had to pull out the card to tell you exactly what it was. So this is a NWA 13250, and it is a pairing to NWA 1950, I believe, is a 5.8 gram pointy or poikilitic Shergottite. And one thing that I found really interesting, and if you look right there, and honestly, I have not put this under the microscope yet, but there's a really vivid white dot.
Yeah.
Yep.
And it's noticeable to the eye when you're just holding it in your hand. I just recently, as of about a month ago, got a nice microscope. And I haven't taken it out since then, but I'm going to investigate that and look at it a little further. This one was Mauritania in 2019.
Super
and then my only other Martian is this one right here. Now this one is a Nakhlite. This is Hassi Messauoud 001.
Oh, nice.
And this is 0.98 grams. This was found in Algeria in 2021, classified by Daniel. And this is almost an entire gram of a known 75 gram fall.
You can
or
round
fine,
up.
Sorry.
From 0.98, you're allowed to round up, man.
Yeah. So this is my 1 gram piece of Nakhlite.
Thank you.
Wow.
Well, and isn't the classification holder of that our friend Matt?
I believe that's true.
Yeah,
Matt Stream.
Yeah. Wow, that's a beautiful piece. I have crumbs of that in a little glass vial.
Yeah, I'm gonna flick the little crumbs back from my fingertips onto the piece so I can preserve those for later.
Seriously, guys, anytime you start messing with Mars, you start getting micros. It's just a nature of the game. That's why, like, I don't know how you could ever cut Martian. That's just a whole thing I can't fathom right now.
Sacrilege.
Yeah.
It depends. Some of them are solid.
Yeah, this big 43 gram one is pretty solid, but I know I'd lose some stuff on the outside, and I'm just that hurts. So that was super fun, guys. Thanks for joining us on YouTube for our Mars education and show and tell. We'll be back in 2 weeks with the moon. See you guys. Thanks, everyone. Bye.
Bye.
Hey.
Bye.